Good afternoon, everyone. So my name is Haopei Wang. I'm from the network engineering team at ByteDance. So it is really my honor to present our paper, NetAssistant, dialogue-based network diagnosis in data center networks. So this paper is based on an internal tool we have deployed in our production network for more than 4 years. And in this presentation, I want to first elaborate the motivation and the high-level idea about this project. Next, I will explain the detailed design of our deployed tool in our production network named NetAssistant. And then I will show the deployment details and the gain achieved by this tool so far. And at last, I will share several lessons learned and our follow-up work in the future. So first, as we know, in today's data center networks, so because it's very huge scale, so achieving high visibility is very important. So this is especially important for our network users because maybe during network changes, so the outage happens and our network users, they are running application or services that may face some likely caused by network issue problem. So then our network issues will be very eager to, first, they want to know whether it is caused by network issue. If yes, so where is the issue, what is the impact, and how long it can recover, right? So they are very eager to answer this kind of questions. In almost all big companies, so they have a very good on-call or ticketing system. So the network users, when they face likely network issues, they will try to turn to raise network on-calls or tickets. So the network on-calls, normally the network on-call people are network engineers, or we call it site reliability engineers. So they handle this on-call request or tickets, and normally they need to finish the ticket within at least hours normally. In almost all big companies, they all have a standard operating procedure for the on-call. For example, they need to go through a number of different monitoring dashboard or logs or a lot of incident records and try to diagnose its problems and provide answers to the users. However, we noticed that this is very time-consuming and labor-intensive work. So why? Because in current data center networks, so first, the monitoring data volume is very huge. And second, maybe other people don't know, so there are tens of thousands of different small instances happen every day. So those small instances may not directly impact the user impact, but they happen, for example, randomly drop a packet, for example. So the on-call people, they are really have a heavy work and they are under pressure. So they really need some help for the R&D team. So we believe there's a gap, and we would like to bridge the gap and help this network on-call people. And we have a very thorough measurement study about our collected user questions, the monitoring data volume, and the daily network incident in our paper. Yeah. So that motivated us to build an automation tool to bridge the gap. So our idea is, can we leverage the idea of a task-oriented dialogue system to or called a chatbot to automatically answer diagnostic questions from users? That is a very interesting idea. And but to achieve that, so we think the chatbot need to have at least 3 layers of abstractions to achieve that goal. So the first is we want to provide a network user some place to chat, to have a dialogue, right? So we need a front end and also some place to maintain the dialogue between the bot and the user. So we need a chat layer to provide a chat service to our users. So accordingly, we design a component, we design a module called dialogue engine to achieve this abstraction. And second, when we have some place to chat, we need to execute the detailed diagnostic workflows. So we call this layer as workflow layer. So its main functionality is to store and execute the diagnostic workflows. So we call this module as workflow engine. And since the workflow layer need to retrieve a lot of monitoring data, so then the workflow layer can generate a corresponding diagnostic result. So we need a data layer. So its main functionality is to provide the abstraction of the underlying monitoring data and also provide the data retrieval functionality. So we call this module as a data engine. So this is our main idea about this chatbot. And I would like to introduce the workflow engine first, because all workflows need to be ready before our bot can start to serve for our users, right? So then how to generate the diagnostic workflows becomes a problem. So we first turn to our network engineers, because we argue that network engineers have the most say on how to diagnose network problems, since they have years of hands-on experience and a lot of network issues caused by some vendor-specific bugs or vulnerabilities. So they have a lot of experience. So we first want to we really hope network engineers can share their knowledge about how to do daily troubleshooting and diagnosis. So that motivates us to provide a platform to let the network engineers to share their experience. So we provide so in this platform we provided our network engineers with a set of autonomic functions for them to use. So what are the autonomic functions? The autonomic functions may include maybe the functions maybe can query monitoring data or do some detection or make some decision or even perform some operations. So we would like our network engineers to use these atomic functions and as building blocks and then assemble their troubleshooting knowledge. So after using all the atomic functions, so all the knowledge and experience from network engineer, they can summarize them into several troubleshooting guides. So here I show an example about a troubleshooting guide. So what the troubleshooting guide looks like. So here is a simplified example about a troubleshooting guide about do a switch reachability check. So we can see from the figure. So for a switch, we can check first whether its metadata is complete or not. It is reachable from a remote pinger. It is uptime looks normal, or it has a very short uptime. So which means maybe it restarts like a short time ago, and how about its BGP peers is okay or not? Yeah, so this is a sample troubleshooting guide. So after the network engineers generated those troubleshooting guide, we need to make those troubleshooting guide to be executable. So then we have a called a workflow converter. So it's more like a compiler to convert all the workflows into all executable workflows. And then we will store these workflows for the future use. So this is the main functionality of the workflow engine. Then, okay, now we have the workflow engine and we have all the executable workflow ready. Then the next step will be, it's time to take and understand our user question, right? So, and our idea is we want to leverage a typical task-oriented dialogue system. So what is a task-oriented dialogue system? So it is, first the user may ask some questions as queries, and then we have a natural language understanding module. So the natural language understanding module mainly to understand the two things from the users. The first thing is called word slots. So the word slots, or it's, we can call it all features or parameters. It's something like maybe we can extract some IP addresses from the questions, extract the subnet, some a lot of names, right? Device names, data center names, any names, or some keyword or the timing from the user questions. So in the ARP research domain, they call it the word slots. And the second thing, the understanding module need to understand is the intent from the user. So what is intent? Intent means what kind of questions is this? Like for example, is this the user asking a server-related question, or a switch check-related question, or something related to like computing services, computing application? So the intent means what kind of questions so the user is asking. Then after understanding both the word slots and the intent, then it will goes to the workflow library. So the intent is according to a specific workflow, and the word slots according to the parameters, and then we can execute the corresponding workflow and then generate the diagnostic result. So this is the major functionality of the second module called the dialogue engine. Okay, now we have workflow engine, and then we can understand the user questions and execute the workflows. Then we introduce our third module called the data engine. So the major functionality of the data engine is to provide the abstraction of underlying monitoring data and also provide the data retrieval functionality. Then with the corresponding monitoring data, then we are able to generate the diagnostic results. However, we find the performance bottleneck of the entire system is about data retrieval. Why? Because querying the cloud network monitoring data is very heavy. Think about, for example, if you want to query, for example, 1 hour of S-flow data for 100 different links, or think about query the switch syslog for 1,000 switches within 1 hour. So that is very huge. So you really cannot achieve that within a few seconds. So we think this is really the performance bottleneck of the entire system. So we need some optimization to address this issue. We notice that for diagnosis purpose, normally only anomalies or jitters are important to us because, for example, for the syslog, we only care about the exception or error log, right? So for other logs, so maybe we can directly ignore them. So that motivates us to achieve a trade-off between the performance and the timeliness. So what does that mean? So we combine the reactive on-demand querying and the proactive alerting together. So reactive or on-demand query means we query those data on demand for some low volume data, like for example, the topology metadata, we can retrieve them within a few seconds. So we query them on demand. And for the high volume data, like for example, connectivity data, traffic data, or some syslog data, we do proactive alerting, which means we set some counters or the always on counters, and then they keep generating the alerts. So we query the alerts instead of query the original data. And by using this, we achieve the trade-off between the performance and timeliness to achieve the performance goal. Okay, and then I would like to demonstrate some very interesting dialogues between users and our NetAssistant bot. So in the first dialogue, so the user asks a very simple question. So please check my server. Okay, so this is the most commonly happened case because for most of our network users, so they are willing about the servers they are using or the data center they are using, right? So they may not have that much a cloud domain knowledge. So the most common question is they ask to check their server networks environment, and so the intent is clear and the objective is also clear. So the NetAssistant do a diagnosis, like for example, check its metadata, check its software stack, CPU memory, the network configuration, and it's nearby the top of rack switch, any CRC, any switch abnormality, and generate the result. Okay, and the second dialogue is the user asks, so the user may be running some application and I didn't notice there's an outage last night. So the user asks the bot, how was the network last night at around 9 p.m. So for the bot, the intent is very clear and it can extract the time parameter, but the objective is not that clear. So the bot can we ask the user again. So I'm not very clear about. So what you are asking, could you please provide some more information? Like for example, provide a name of the network. So you're asking which data center, for example. Suppose we have the data center in Santa Clara here. Okay. So the user may ask, okay, have me check the Santa Clara Santa Clara data center. And then both intent and the objective is clear. Then our network system will do the diagnosis. Like for example, check all the connectivity data, like IP version 4, version 6, the external connectivity, the traffic in terms of total or queues data, and its routing is healthy or not, and then generate a report. Okay, so the network was very healthy last night at 9 o'clock. So probably this is not a network issue. Okay, and I would like then to introduce the deployment and our game. So the first version of NetAssistant was launched in April 2020 under the background of pandemic and work from home. So it started with only 2 workflows, and we keep iterating the tool in terms of technology and functionality. So right now, it has more than 100 workflows and have more than 20 users per day. So our main target to have this project is to save human labor time. So after getting responses from bot, so ideally we want like the on-call can be stopped. So and although some responses from the bot cannot be fully satisfied by and trusted by our users, so they may still raise human on-call, we still believe that the information provided by the bot is still very useful and can help the speed up the on-call process. So then we evaluate several things to support. So first, we measure how many questions can be intercepted by this bot. So we show 3 months data last year, and it shows that almost every day, at least half to 90% of user questions can be intercepted by this bot every day. And also, we measure with and without our bot. So the distribution of the on-call duration time. So the result shows that on-call takes tens of minutes, and the bot responses can save around 25% of total on-call time. And we have several lessons from this project. First, so as an internal tool, earning user trust is very important. So we provide customer services, and we prioritize the accuracy first. And the second, we found that the false negative is more harmful than false positive. And the third is, so actually we found the bot in empowering our user. So we found like after using our bot for some time, so the user can ask a more concise and clear question. Yeah, this is a very interesting observation. And we have like some follow-up work. So first, so this is the chatbot paper, right? So of course, right now the large language model is very hot, and we are now exploring the potential of large language model in the AI ops and also network troubleshooting. But we found several challenges, like understanding the diagnosis logic is very challenging, and also processing real-time monitoring logic data is also very challenging. Yeah, this is all about my presentation, and I'm very happy to take your questions. Thank you.